All right, velocity. Okay, what is velocity? All right, velocity is speed in a given direction. Speed is still distance divided by time, but now all we're doing is going to add a direction. So if I'm describing velocity, I might say 55 miles per hour north, 55 miles per hour south. So all I'm doing is attaching another unit of measurement, in this case, direction. If I ask you to calculate the speed, you just give me the number and the unit of measurement, 60 miles an hour. But if I want the velocity, 60 miles an hour south, north, upstream, downstream, okay? Things like that. Okay? So that's really the only difference between speed and velocity. You're still using the formula for distance and time. For speed, I mean, distance divided by time. That doesn't change. Okay? So make sure you understand that. All we're doing is now just telling us what direction that object is traveling in. Okay, that's all velocity is. All right. So, here in this example, what is the velocity of a plane leaving from Boston and heading to LA if it travels 3,200 miles in 5 hours? Okay, remember, velocity is speed, but now all we want to do is attach a direction. Okay, so the math is easy. We can divide 3,200 miles divided by the 5 hours. That's distance divided by time. That's going to give us the speed of the plane. But we want to know the velocity, so we're going to add the direction. Okay, so the distance is 3,200 divided by the 5 hours. Okay, direction is west, Boston to LA. So a correct unit of measurement here would be 640 miles per hour west. Okay, now if you didn't know the actual direction, like west, you could still put 640 miles per hour from Boston to LA. That's still a directional command. Therefore, all right, measuring velocity. All right, so let's do a couple of practice problems, okay? Because over the next week or so, we're going to get plenty of work working on these. I think understanding how to do mathematical problems in science is very important. You have to keep it simple. Read the problem, identify the formula, insert the numbers into the formula, and then calculate. All right, so here, number one, a girl cycles for 3 hours at a speed of 40 kilometers per hour. What distance did she travel? Distance, if you go back to that other slide, speed times time. Well, the speed is 40 kilometers per hour. The time was 3 hours. What distance did she travel? All right, so let's identify the formula. Distance, speed times time. Two, insert the number from the problem into the formula. And that's exactly what I did here. The 40 kilometers per hour is the speed, the 3 hours is the time. All right, now from here, let the calculator do your work. Okay, 40 times 3, all right, is 120. So the girl cycled 120 kilometers in 3 hours because she traveled at a speed of 40. Now, if I'm going too fast, you can always hit the pause button, all right, and rewind this problem if you need to. All right, so this was a problem using the distance formula. All right, we're going to do one of each. All right, here in this problem, a car travels a distance of 540 kilometers in 6 hours. What speed did it travel? Okay, so you look at your formula down here below. Speed is distance divided by time. Okay, so let's identify the formula. Speed equals distance divided by time. Now we got to plug in these numbers into the formula. So which one's the distance? The distance is kilometers. 540 kilometers. I'm going to divide that by 6 hours. All right, as you see here in step 2, 540 divided by 6. All right, now from here, just let the calculator do the work. I don't expect you to know it in your head. You don't need to. I just need you to know how to insert the correct numbers into the formula. All right, the right way. So here it's 540 divided by 6, not the other way around. If I did 6 divided by 540, it would give me an incorrect answer. All right, so correct answer after we calculate is 90 kilometers per hour. All right, so this car traveled at 90 kilometers per hour in 6 hours and did it in 540 kilometers. All right, and the last example that we got to cover is one on time. Okay, or how long something goes. All right, how long? Look at the cue. Okay, how long? How long does something take? Well, we're describing time. All right, so here, a train travels a distance of 1,000 kilometers at a speed of 50 kilometers per hour. How long did it take to travel there? Okay, we identified our formula, and time is distance divided by speed. So which one is the distance? That's right, 1,000 kilometers. What was the speed that it traveled? Well, kilometers per hour, all right, is a unit of measurement of speed. So that must be where the 50 goes. All right, plug in our information. We got 1,000 kilometers divided by 50 kilometers per hour. So how long did it take this train to travel 1,000 kilometers? It took 20 hours. All right, very, very simple, guys. Okay, this is physical science, not rocket science. All right, like I said, each one of these problems I've done in 3 steps. We identified the formula. We inserted the numbers into the problem, into the formula, and then we calculate. Keep it simple. Okay, trust me, keep it simple, and you'll never make a mistake. And another one key point I do want to add is get in the habit of putting the units of measurements next to every number. Very, very important. I can't stress that enough. All right, because as problems get more difficult, you need to know what the units of measurements are. All right, because, look at the number 20 here. 20 hours, 20 seconds, 20 miles, 20 meters, 20 days. All right, we can use that 20 in 100 different ways, but the unit of measurement tells me what that number means. So in this case, 20 hours. Kilometers cancel out. All right, if I had a pen, I'd cancel them out. Kilometers and kilometers, and that would leave me with hours. Boom. Okay. All right. Okay, so just a quick tip. Anytime we are solving a scientific math word problem, look for the clues inside the problem. They always tell you what formula to use. Once you identify the formula, insert the numbers from the problem into it, then calculate. So you see a clue. How long? That's talking about time. How far? Well, distance. How fast? Speed. So look for the clues in the problems. It will definitely help reduce error in calculations. All right, so we saw this graphic earlier, a few slides ago. So I just want to go over them real quickly. All right, anytime you're looking at a distance time graph, all right, you'll see different kinds of lines on it. All right, so the green line here, objects that travel very far in a short amount of time. So here we have a steep slope. So if you look at this green line and this part of the red line, they're 2 straight lines. They're both representing steady speed, but one is representing a much faster speed, all right, an increased slope. All right, when you think about it, it's traveled a further distance, okay, than this segment of the red line, all right, but in the same amount of time. All right, so in order for an object to go faster, it travels farther in a shorter amount of time. Okay. What does the blue line represent? I talked about that earlier. All right, a steep curved line. All right, in this case, a curved line going upward. All right, this means it's getting faster. Another word for getting faster is acceleration, which we'll get into after this part of the unit. Okay, so a curved line, it's not constant speed. All right, because the speed is changing. It's getting faster as it travels further. Okay. And then the red line. Well, the red line, we got a lot of stuff going on. We already talked about what this part of the red line meant. This was a constant, steady speed. All right. But remember, from that first graph, what does a flat line mean? Distance time graph. It means it's stationary, no movement. All right. If you look at distance, okay, the distance here to here, there's been no increase in distance. Therefore, no movement. Okay. No movement. All right, so just look at the red, green, and blue lines, kind of tells you a little bit about some of the different types of motion, all right, that could be represented on a graph. Okay, and last but not least, All right. And at this point, you probably should pause it. I would highly recommend you just give these practice problems a chance. All right. See if you can do and execute what we just talked about. In each of these problems, I've bolded, all right, some clues, which will tell you what unit, what formula to use. Okay. And then use the units of measurements in the rest of the problem to uh, decipher where they're going to go in the formulas. All right. So, number one, Peter is a runner. He runs the 50-meter sprint in 5 seconds. What speed did he travel at? Well, speed, all right. If you don't remember the formula, go back into the video and look. Distance divided by time. Peter ran 50 meters in 5 seconds. Distance divided by time. All right. So, I think we can all do that particular math in your head. So, give these 5 problems a shot. Just do them on some scrap paper. All right. Pause the video, give them a shot. And then on the next slide, you will see all of the correct answers. All right. Test your skill. Don't just look, test your skills. At this point of the video, press pause.